Hello and welcome to this video on tolerance stack-up analysis, in which I'll be taking you through a case study on the assembly stack-up of a control arm. So basically a control arm is a component which is used in suspension systems as shown over here. So this is a double wishbone suspension system. It has an upper control arm, it has a lower control arm. So we will be taking the scenario of the assembly of the upper control arm, and we'll be doing a stack-up of the assembly of the two bushes of the upper control arm into the brackets on the chassis. So here is the CAD model of the bracket on the chassis, and this is the assembly along with the control arm, and we will be finding out whether the control arm with the given tolerances will it assemble in the worst case or not for this kind of an assembly. And also we will find the maximum gap between the sheet metal bracket and the control arm bush, which is shown over here. Here are the drawings for both the parts which are being assembled. This is basically the sheet metal form brackets which will be welded on the chassis on the left hand side, and this is the control arm assembly which has the bushes shown over here. The width of the bushes is 39 plus or minus 0.4 on either side, and the width, the cavity within which they will be assembled on the chassis, is shown over here, which is 42 plus or minus 0.8. So these tolerances of course will be driven by the manufacturing processes, the specific manufacturing processes. So the tolerances on these widths, for example this plus or minus 0.8, plus or minus 0.5, plus or minus 0.8 will be dependent on the accuracy and precision of the sheet metal forming process. So you can see the difference over here. Since the pink color brackets are being welded to the center press bake formed part, which is nothing but the spring dome. So the spring dome width will have a lesser tolerance or a tighter tolerance because of its formed as a single part as compared to the welded brackets on either side, because there will be weld distortion which will come into play. Hence this plus or minus 0.8 will account for that. So on the right hand side, the control arm is cast plus machined. Hence casting related tolerances and machining related tolerances will be applied. Of course, these tolerances are generally considered as on the higher side for a machined part. We'll consider this and do the tolerance stack-up analysis and see whether we will be able to assemble the control arm in the worst case or not. The first step is to create the loop diagram. Now to create the loop diagram, we need to consider a scenario when the control arm is being assembled and being contacted on one side. So let's say if the control arm bushes are assembled into the cavities and they are being contacted on one side, and because they are being contacted on one side, because of the gap between them, there will be some gap over here in between this bracket and the control arm bush. So there has to be some gap, only then they will assemble. So considering this as the best possible case scenario, considering that there will be a gap over here, we are contacting one side of the bush to the bracket. So now we can create the loop diagram. So first thing is we need to calculate this distance from this edge, the inside edge of the pink color bracket, to the outside edge of the bush of the control arm. That is what we need to calculate. That is gap AB, for which the specification we need to calculate whether what will be the gap specification for AB. That is what we are calculating. So that will help us decide whether the control arm will assemble into the cavity in the worst case or not, when the tolerances are at their worst case, maximum or minimum. So for that we need to calculate the specification for this width AB. So the first segment of the loop diagram will be segment number 1, which will start from this point and go to this point, which is nothing but the addition of these three specifications. So segment number 1, specification number 1 is nothing but the stack up of these three specifications together. Then segment number 2 is the specification for the bush alone, which is this 39 plus or minus 0.4, the width of the bush. That is specification number 2. Then from the edge, because we are contacting the edge, inside edge of the pink bracket, the outside edge of the bush and the inside edge of the pink bracket are flush. Hence we are starting from that same point to the other edge of the bush. Then from the other edge of the bush we are going to the this edge of the bush, from this side to this side, from the left hand side to right hand side of the bush. That is specification number 3, which is this 83 plus or minus 0.6. And then from this edge, from the left hand side edge of the right hand side bush to the right hand side edge of the right hand side bush, we are going from this point to this point, which is specification number 4, which is again this 39 plus or minus 0.4. And we have completed the loop from A to B. Then we can calculate the specification for this gap AB and find out whether it will be positive or negative. If it is positive, then there will be a gap and hence we will be able to assemble the control arm in the worst case. If it is negative, then it means that we will not be able to assemble the control arm in the worst case. So let's calculate that. First, we need to calculate for specification number 1. For specification number 1, we can do the general stack up calculation, which is adding up all of the values over here, 42, 80, 42, we will get 164, and also adding up all the tolerances, 0.8 plus 0.5 plus 0.8, which is plus or minus 2.1. So specification number 1 is 164 plus or minus 2.1, specification number 1. Specification number 2 is this over here, 39 plus or minus 0.4. Specification number 3 is this over here, 83 plus or minus 0.6. Specification number 4 is this one, 39 plus or minus 0.4. Now we can create the tolerance table by giving the sign convention and then find out what is the gap AB. So here is this tolerance stack up analysis table to find out the specification AB. So the sign convention is over here on the left hand side top corner. Towards the left is plus, towards the right is minus. So we go first towards the left, specification number 1, which is 164 plus or minus 2.1, and that is in the positive direction towards the left. Then we go from this point towards the right, that is 39 plus or minus 0.4, that is in negative direction. And from here we go again towards the right, that is negative direction, 83 plus or minus 0.6. From this edge again we go towards the right, that is negative direction, 39 plus or minus 0.4. So 164 minus 39 minus 83 minus 39 will give dimension is 3, and tolerances will get added up, 2.1 plus 0.4 plus 0.6 plus 0.4, which will give plus or minus 3.5. So basically what this means is that the gap specification will be 3 plus or minus 3.5, and if we calculate the maximum and minimum gap, the maximum gap will be 6.5 and the minimum gap will be minus 0.5, which means that there will be interference, and interference will cause no assembly, will cause a situation where the assembly will not take place. So control arm will not assemble in the worst case. So as you can see, just by looking at the drawings, you cannot find out whether we will be able to assemble the control arm in the cavity of the sheet metal brackets or not. By doing a tolerance stack up analysis, we came to the conclusion that in the worst case, when they are varying to their extremes, the tolerances, the control arm will not be able to assemble into the cavity. The maximum gap which we calculated earlier, 6.5, is not realistic, and that does not consider the physical constraints of the assembly. So just by looking at it, we can find out the maximum gap which is possible physically because of the constraints of the two brackets on either side of the bush. So that is just a very simple calculation. The 42.8 minus 38.6, which is the maximum width of the sheet metal brackets versus the minimum width of the bush on the control arm. So that will help us calculate the maximum gap which will occur. So 42.8 minus 38.6 is 4.2. When the bush is centered, it will be 2.1 on either side. So maximum gap which is achievable based on these tolerances is 4.2.